Okay, today we're looking at lesson 14.1, geometric sequences defined recursively. We're going to start with task 1. All right, so it says understand a geometric sequence. Recall that a sequence is a list of numbers in a specific order. In an arithmetic sequence, consecutive terms differ by the same number d called the common difference. All right, so here's an example, 4, 7, 10, 13, 16. You can see to get from each one, you add 3 to get to the next one. That's called your common difference. So an arithmetic sequence is made up by a list of numbers that you can add or subtract to get to the next number. That's called your common difference. All right, so now we're going to look at geometric. A geometric sequence is a sequence in which the ratio of successive terms is a constant r, called the common ratio, where r is not equal to 0. The geometric sequence shown has a common ratio of 2. All right, so arithmetic sequence, you add or subtract to get to the next one. A geometric sequence, you have a common ratio, which means you multiply to get to the next term. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So our common ratio is 2, okay? All right, a bungee jumper jumps from a bridge. The table displays part of a sequence that models the bungee jumper's maximum height, f of n, in feet above the water during each rebound n. All right, so we've got a table, and they gave us a picture here. So the first time was fully extended, and then after the first rebound, he rebounded 200 feet. That's 200, and then the second rebound, he rebounded 80 feet, and the third time he rebounded 32 feet. All right, so you can see that this does not go a common difference, so it's probably going to be geometric, which is a common ratio. All right, so the sequence is not arithmetic. Consecutive terms do not have a common difference. Okay, so you cannot add or subtract a number. From 200 to 80 is minus 120, and you can see that this one is like minus, 48? So there's not a difference of a common difference. All right, find the ratio of successive terms shown. Give the ratio in decimal form. Okay, so to do that, you're going to take the second term and divide it by the first term. So 80 divided by 200 is the same as 8 divided by 20. Let's see. We'll go ahead and do 80 divided by 200. Even though you can drop the zeros there, it's going to be 0.4. So I'm going to put 0.4 here. If it has a common ratio, the next one will be 0.4 as well. So let's see, 32 divided by 80. And that one is also 0.4. All right, which statements are true? Select all that apply. All right, so since it has a common ratio, that means the sequence is geometric. The common ratio is 0.4. We just found that. The common ratio is this, no, and there is no common ratio. All right, so it says write the explicit fourth and fifth terms in the sequence in decimal form. All right, so since we have the first 3, we can find the next term by simply multiplying by the common ratio. So all I have to do is take 32 and multiply that by 0.4. So 32 times 0.4 gives me my next term. And then 32 times 0.4 again gives me my fifth term. Whoops, I did 32 again. I got to find that one first. Let's see. So 12.8. And then that would be my fourth term. And then 12.8 times 0.4 gives me my fifth term, which is 5.12. All right, so once you have your common ratio, you just multiply it to get to the next term. That's all of task 1. If you have any questions, please let me know. Lesson 14.1, task 2. All right, express a geometric sequence recursively. By associating position numbers with the terms of a geometric sequence, you can create a function where the domain of the function is generally the set of natural numbers or whole numbers, and the range of the function is the set of terms of the sequence. So consider the sequence 50, 100, 200, 400, and 800. So the position, you're looking at your first term. The first term is 1, 2, 3, 4, 5. So the position or the number is your domain, and then the sequence number would be your range. So this is like your x's and your y's. In this case, we're using n and f of n instead of x and y. Okay? All right, so it says recall that a recursive rule for a sequence gives the beginning term or terms and a recursive equation that defines the nth term of the sequence by relating it to one or more of the previous terms in the sequence. You can write a recursive rule for a geometric sequence. All right, so this is important. Make sure you have this in your notes because you're going to see this a lot. And if you learn what this is, this will be very simple, okay? So your general recursive rule for a geometric sequence. All right, so they always give you your first term. So f of 1 is the value of your first term. And then your equation is going to be f of n equals r, that's your ratio, your common ratio, times f minus n minus 1. And this is always for n greater than or equal to 2. Because we start with the first term here, we don't start with greater than or equal to 1. We always start with n greater than or equal to 2. So this is pretty much standard, okay? All right, consider the sequence 1,000, 500, 250, and 125. Write the ratio of consecutive terms as decimals to show the sequence is geometric and write the common ratio. All right, so if I do 500 divided by 1,000, you can see that that's 1/2. 1/2 is the same as 0.5. If you're not sure, again, just go to your calculator. If you need to double check yourself, and you can just do 500 divided by 1,000. And you'll see that that's 0.5, okay? All right, also 250 divided by 500, that's also a half. 125 is half of this, so 0.5 again. So since those are all common, your common ratio is 0.5. So this is the common ratio for this sequence right here, okay? All right, so it says, let f of n, the value of the nth term of the sequence, complete the equation. All right, what is f of 1? So they want to know what is our first term. Well, if we look right here, the first term of this sequence is 1,000. All right, so it says what is a recursive rule for this sequence? So we know it's going to be the first term, and then it's going to be times the common difference, and then it's time f of n minus 1 for n greater than or equal to 2. And again, that comes from this formula right here that I said that you need to kind of remember. So all we're doing is the first term was 1,000, and then we're plugging in our common ratio, and the rest of this basically stays the same. So if you know that formula, this is not too difficult. All right, so it says write the next 4 terms of the sequence as decimals with no rounding. All right, so we know that f of 5, okay, will come after f of 4. So we are given 1, 2, 3, 4 terms. So we're going to have to take the 4th term and multiply it by the common ratio to get the next term. So we're going to do 125 times 1/2. So basically just half of 125. All right, and then we're going to do 62.5 times 1/2. So we've got 62.5 and 31.25. All right, now we need to find the next term. So take 31. You can also do second minus, and it says it pulls down the answer from the previous line and then just do times 0.5. Or you can just type it in, 15.625. And then the next term, do the same thing. So I'm going to take my previous term and times it by 0.5. And that's 7.8125. All right, so you take whichever your previous term is, multiply it by the common ratio, and that gives you your next term. So when it says of f of n minus 1, this is the symbolism for your previous term. That's how we know to get to the next term, I'm going to multiply the common ratio by the previous term, and that gives me the next term in the sequence. All right, that's all for task 2. If you have any questions, please let me know.